When protons and neutrons get directly involved in reactions and their numbers do change, huge amounts of energy can be released, far more than by the transfer of electrons that we've learned about in other reactions. When these changes happen to the nucleus of an atom, we rather logically call their study nuclear chemistry.
Nuclear chemistry. Reactions that involve transmutation. Transmutation may be natural or artificial, and transmutation results in the conversion of one element into another.
I'm waking up to ash and dust. I wipe my brow and I sweat my rust. I'm breathing in the chemicals.
Understood. Most people think of radioactivity as just something that mutates genes and melts faces off. And yes, some forms of radioactivity can do those things. But all the more reason to understand it right. And also we can harness it to produce lots of electricity to fuel our rock and roll lifestyles without contributing to global warming, though, as Fukushima has taught us, it comes with some of its own problems.
Radioactive emissions. The major particles emitted by radioactive isotopes, radioisotopes, are shown below. Penetration power of particles. Alpha particles have the least and gamma the most penetrating power. Gamma radiation is high energy and causes mutation to DNA in cells.
Natural transmutations. Alpha decay. Nucleus emits an alpha particle. Beta decay. Nucleus emits a beta particle. Positron decay. Nucleus emits a positron particle.
Both of these kinds of changes, changing one element to another or changing one isotope to another, are known as transmutation. And it is indeed possible to transmute lead to gold. It's just so ridiculously expensive that the tiny amounts of gold produced could never pay for the process. Let's take a look at what may be the most famous radioactive element, uranium. By far the most common naturally occurring form of uranium is the isotope uranium-238. More than 99% of the natural uranium in the world is in this form. U-238 spontaneously decays into thorium-234 in a process that releases something called an alpha particle. This is called alpha decay, and the particle that it emits is basically the same as a helium nucleus, 2 protons and 2 neutrons.
He went from science sweetheart to nuclear skid row. Hear about his rise, fall, and valiant climb back on The 9 True Science Story. After World War II, America found a new hero. A hero whose name would be known around the world. Our friend, the atom.
I was young and cocky. You know how it is. When you're young, you think you can do anything.
Indeed, his future seemed limitless.
That stuff was made up by the press and my promoters. I never said I could do all that stuff.
The 60s generation turned against Mr. Atom.
All of a sudden, I'm not the friend anymore, you know? All of a sudden, I'm not cool. That really messed me up. There's not a day goes by that I don't wish I could go back and change all those errors. I'm sorry. I'm sorry. Can we stop? I need a break. Just a sec. It was rough. I thought I was all bad. There's been some mistakes in the past, but I'm not ready to pull the plug just yet. America still needs me, and I'm going to find a way to be our friend, the atom, again.
Now, you might have heard of gamma radiation more than the other kinds I've mentioned because it can actually do some serious harm, like potentially turning you into a giant green rage monster that doesn't obey the laws of conservation of matter.
Biomedical testing was extensive on Plumbob. The major portion of the experimentation was devoted to furnishing information on the effects of nuclear weapons on the large biological specimen, the pig. Early in the plumb bob operation, 135 pigs in aluminum containers for protection against blast and thermal were exposed to the Franklin shot to determine the effects of combined neutron and gamma radiation and straight gamma. Franklin's extremely low yield made it necessary to repeat the experiment on shot Wilson. Wilson's higher than expected yield, along with a neutron line not shielded as well as Franklin's line, gave the pigs a greater radiation dose than desired. With only 2 animals living beyond the 30-day observation period, the relative biological effectiveness of neutrons was not obtained. On DoD shot Priscilla, 710 pigs were stationed at overpressure ranges of 10 to 1.4 psi in an arrangement to obtain a wide selection of combinations of radiation, thermal, and mechanical injury effects. The 4 midline stations were glass-fronted to serve as missile sources to obtain wounds for medical and surgical treatment evaluation. After the fury of the Priscilla burst had spent itself, a round-the-clock operation was set in motion, beginning with biomedical teams hurrying in to recover the animals. Of the group exposed within the precursor range, the primary cause of death was mechanical injury to the organisms due to translation. The mortality rate, nearly 100%, can be applied to man. Outside the precursor, those animals in the open which escaped total missile injury survived temporarily until the massive radiation they received took its fatal toll. Flying glass fragments did not significantly influence overall mortality. In the range where missiles produced a considerable number of wounds, most of the animals received lethal doses of radiation. Many in this group also received serious thermal burns. Due to the small number of survivors with the desired thoracic and abdominal wounds, evaluation of the medical and surgical treatment phase of the experiment did not produce conclusive results.